Hello everybody. Welcome to creating the basic adaptable game engine library, part 13, the sprite, group, and entity class design. In previous videos, we've started putting together the classes that we'll need for the sprite class. In particular, each sprite will have a position on the screen, represented by the vector class, a boundary, represented by the rectangle class, and a texture, which contains image data used for drawing it on the screen. So you might wonder what these other classes are for and why we need to talk about all of them at once. We'll create a class called group to manage collections of sprites, and we'll actually need to create a superclass called entity. In this video, I'd like to talk about why. So our very first game will be a game called Starfish Collector. In that game, you'll control a turtle which moves around the screen and collects starfish, probably more than one. And later on, we'll add other types of objects, for example, rocks that the turtle needs to move around. So there's certainly a need to manage collections of sprite objects. For instance, for game logic purposes, we'll want to check to see if a turtle overlaps any of the starfish objects, and if so, we'll remove the starfish from the game, indicating that it's collected. Or for example, we'll want to check to see if the turtle is overlapping a rock object, in which case we need to prevent collision from that somehow. So we need to compare objects against each other for game logic purposes, and so we'll need to group them together. But also we need to draw all the different sprites in our scene. So we need to keep track of a kind of a master collection of all the different sprite objects. So we can think of the game objects as being naturally collected into a set like this, right? A set containing, this is for our first game, the turtle sprite, but also the set of game objects contains a set of starfish objects, a set of rock objects, and maybe other objects as well. So there's kind of this nested group structure that we'd like to be able to implement. And therefore, we're going to say that, well, a group can be a list of individual sprites, or also a group can contain other groups. This is a little bit tricky. It sounds a little bit recursive almost. The way we implement this in code will be, we need a superclass, right? We can't just create a list that accepts sprites or groups. What we can do is create a superclass which we call entity. An entity can be either an individual sprite or a group of sprites. And therefore our game objects will be a list of entity objects, where entities are these two special cases. And then when it comes to drawing images, right, we don't need to maintain, right, one list for all the sprites to be drawn and then a bunch of separate lists. We can have one master list and tell our program to draw everything in this group. There will be code for drawing individual sprite objects, but it will also be able, or it will be possible to draw a group. The way you draw a group is you apply the draw method of every entity within it, whether those entities are sprites or even more nested groups. So this is the reason we're going to create an entity class as a superclass for both groups and sprites. All right, now we should take a look at maybe the Java documentation to see what code we're about to write. So here's the master Java doc file up to this point in the course. So first, we have the superclass, a class called entity. This is going to be an abstract class. You can't create an entity, but you can create one of the subclasses, either group or sprite. As we mentioned before, it's going to be the base class for all objects or collections of objects that can be rendered to the screen. All right, so again, there's really not a constructor for entity since it's abstract, but there will be an abstract method which needs to be implemented by the extending classes, a method called draw. Again, sprites will have some very specific draw information, which takes into account its position and its texture. Group will implement this in a different way. A group is drawn by drawing everything contained within the group. And this method will require a JavaFX class, which we'll talk about in a future video called graphics context, and it's used to draw images onto a canvas. And that's something which we'll talk much more about in a future video. And so this is the entity class. One of the subclasses is group. Right? It extends the entity class, and it's just a collection, really. Let's see. So within the group class, you can kind of think of group as maintaining a list. And within that list, we have some helpful methods to help us work with that list. So we can create a group, which is going to initialize an internal list, as we'll see soon. We'll be able to add an entity to that group, whether that entity is another group or an individual sprite. We'll be able to remove entities from a group. There's one method which will provide access to the list within the group. The list itself will make that a private class variable, and we're going to create a method called getList. But getList isn't going to return the list directly. It'll actually retrieve a shallow, we say, copy of this list. The reason being, there's an error you sometimes run into when doing game development in Java. Imagine that you're iterating over a list of objects, and within that loop, you want to remove one of the objects from the list. You can't do that. You can't modify a list while you're iterating over it. It's something called a concurrent modification exception. It's a pain to deal with, but we'll create this method called getList, which will allow us to avoid ever having to experience that problem. We'll talk more about that later. Also, for convenience, there will be a size method, which will determine the size or return the size of that collection of objects. And finally, a draw method. Right? A group will draw itself by drawing or applying the draw method to all of its entities in its list. So that's the group class. The other class which we're going to be interested in is the sprite class. Sprite class, see, there's going to be a constructor, and for now, we'll set a lot of the fields by hand. We'll talk more about what constructors would be useful later on. One of the fields will be a vector to store its position. There will be a texture, which is going to contain the image data we need to draw the sprite. There will be a rectangle, which will be used for collision detection when two rectangles overlap. We'll also store the width and the height of a sprite. And this might sound redundant, but truly it's not. The width and the height we want to use to draw an image might be different than the width and the height of an image itself. We might want to stretch or shrink an image when we render a sprite. And you might think also, maybe we should store both width and height in a vector. You could do that. Because vectors have x and y as their components, it's a little bit awkward, I think, to call x width and y height, but you could also write the class in that style if you wish. And some sprites will not be visible at the start of the game, like for example, sprites representing messages which appear later on. And so we'll also include a boolean variable which will determine if the sprite will be drawn. And constructors we'll talk about later. Also the draw method For now, when we implement it, it'll be empty. Later on, once we talk more about JavaFX and how graphics are drawn to the screen, we'll come back and implement this later on. But those are the three classes we're going to be working on next, and that's kind of how they fit together: entity, group, and sprite. In the next few videos, we'll start to implement the code for each of those classes. All right, thanks for watching.